Next one we're going to look at is number 38 right here. Okay, and now I have a binomial radical, square root 2 plus 5 square root 5. It's got two radical terms times another binomial. So think about what you did algebraically. You're going to do the same thing. You're going to either FOIL or distribute twice, whatever you want to call that. Let me make this a little bit bigger here. So I need to take radical 2 times 4 radical 2. Now if I do that, radical 2 times 4 radical 2, this is like 1 radical 2. I do 1 times 4, which is 4. If I multiply the things underneath, I get radical 4. But square root 4 can be broken down into 2 times 2. You pull the 2 out. Now there's a shortcut. I don't even write that as radical 4. When I am taking a radical of some number times that same radical of that same number, the output is just going to be that number without the radical on it. Okay? So it really ends up being 4 times 2 right there, which is going to be 8. So when I do radical 2 times 4 radical 2, it ends up being just 8 without a radical on that term. Then I distribute my radical 2 times radical 5. No numbers out in front, so I'm going to get plus radical 10. Now I'm going to take the second term and I'm going to distribute that to both. I have 5 radical 5 multiplied by 4 radical 2, which is 20 radical 10. So plus 20 radical 10. And then I have 5 radical 5 times radical 5. So this is going to bring that back into play, what I talked about up there. When I did radical 2 times radical 2, it was 2. When I do radical 5 times radical 5, it's the radical 25, which is just 5, square root of 25. So it really ends up being 5 times 5, which my last term here will not have a radical on, which is 25. Now I have 4 terms, 1, 2, 3, 4, and I ask myself which are like terms. Well, I have my two constants, 8 and 25, without radicals on them. They can be added together to 33. And then I have radical 10 and 20 radical 10, both radical 10s. I can't simplify radical 10 at all. There's no pairs to pull out. This is 1 radical 10, so when I combine them, I add my 1 and my 20, which is 21 radical 10. I cannot go any further than that. Now, a lot of kids want to add the 33 plus the 21. You can't do that because the 33 doesn't have a radical 10 on it. It's almost like saying if I had 33 plus 21x, you can't combine the 33 and the 21 because this has an x on it and this doesn't. That's as far as you can go. It's very similar with radical terms. I want to make one comment about number 40. On number 40, let me move this down a little bit, but we have this. We have radical 2 plus radical 3 squared. A lot of kids mistakenly will think that you can just undo and it's going to be radical. You can square this and square this. When you have a binomial squared, you can't do that. And this is going to come into play with other things too when we get to complex numbers and things like that. You actually have to write it out. Squaring it means to multiply by itself. And now you will FOIL or distribute twice and go through that same process I just showed you on the last problem. Okay, so you have to write it out multiplied by itself whenever you have a binomial squared. Common mistakes we see on that problem, so be careful.